from Prelim 2018, the recent Prelim, okay, from other schools. So they are very relevant, and it is also serving as an exercise for you to recall, okay, how to write down the explanation and also the equations. Okay, so for this particular topic of periodic table, okay, the ownership is on all of you to really go and understand and be able to recall, okay, how to write the explanation and also how to write a balanced equation. So when I start to read this question, okay, an experiment was carried out to determine the relative oxidizing power. So first thing I'll take note of is oxidizing power. Then of three unknown halogens. Once I see oxidizing power, halogens, then what needs to go through my head is that I need to start to think, okay, what is the trend, okay, of oxidizing power down group 17? Okay, you should be able to recall that oxidizing power actually decreases down group 17. And why is it that oxidizing power decreases down group 17? Okay, it should be based on the explanation of the ease of gaining electron. Why the ease of gaining electron? Because if your halogens are oxidizing agents, okay, meaning to say that it will oxidize other species, itself will undergo reduction. If itself undergo reduction, it will be gaining electron. Reduction, gain electron. So how easy it gain electron will determine its oxidizing power. So, okay, this is what I need to recall once I start to read the question. If you cannot recall this, you need to go back to your lecture notes again, okay, to understand. Okay, after I have know this, I'll move on to look at the table. Okay, first thing, I'll look at X2. If you look at X2, what happens is that, okay, X2, okay, reaction with Y minus. X2 is the halogen, X minus would be what we call the halide ions. Okay, X2, Y minus, there's no reaction. Okay, meaning to say your X2 is unable to oxidize Y minus. Okay, X2 is unable to oxidize Y minus, hence no reaction. Same, X2 with Z minus, X2 is unable to oxidize Z minus, hence no reaction. Meaning to say that from here, I should know that X2, is it a weak or strong oxidizing agent? It should be a weak oxidizing agent. It is unable to oxidize Y minus, it is unable to oxidize Z minus. So just based on this piece of information, can you make a rough guess what is the identity of X2? We know that the general trend is that oxidizing power decreases down group 17. Meaning to say that, okay, Cl2 as compared to Br2 as compared to I2, the one with the strongest or the highest oxidizing power would be Cl2. Okay, I2 would be the weakest oxidizing agent. Hence, I should be able to conclude that X2 is iodine. Can get? Meaning to say that Y2, okay, it is able to oxidize both X minus as well as Z minus. So Y2 should be the one that is the strongest oxidizing agent, chlorine. Z2, bromine. So from here, I should be able to get the respective identity of X, Y, and Z. Take note that the question is asking you about the identity of X square, X2, Y2, and Z2. Okay, they are your halogens. So if you give your answer, okay, as halide ions, meaning to say that you say that X is actually your iodide, Y is your chloride, Z is your bromide, you will be penalized. It is not correct. Okay, so take note of what the question is asking. They're asking you for the identity of X square, Y square, and Z square. So it should be iodine, chlorine, and bromine. Then the next question I want to pose to you is that if let's say, okay, this is not in the question, but if let's say the question tells you, here they tell you that the observation is a brown solution. So why is it that it will form a brown solution when I react chlorine with X minus is actually your iodide ions? Why? Can you write out an equation to tell me why is it that when you react chlorine with iodide ions, it will give you your brown solution. I repeat again. When I react chlorine with iodide ions, it gives a brown solution. Can you represent this with a balance equation? So your Cl2 will be able to react with your I minus, 2 moles of it. Okay, it will actually form I2 and Cl minus. This is the balance equation, and then the I2 in the aqueous solution, it will appear as brown. So that is why you get a brown solution. Similarly, why is it that when you react, you know that your Z minus is actually your bromide ions? Why is it that you react chlorine with your bromide ions, you will get an orange solution? The orange is actually due to the presence of aqueous bromine. Okay, so I should be able to write out the balance equation for this as well. Okay, Cl2 reacting with your Br minus, 2 moles of it, to give you Br2 plus 2Cl minus. This Br2 is in aqueous solution, hence it is orange. Can follow? Okay, so just take note of this. Then, of course, the next part, when they ask you which is the most powerful oxidizing agent, you should be able to tell me that chlorine is the most powerful oxidizing agent. Okay? Now, in terms of the explanation is actually given in your lecture notes. You need to be able to recall this explanation. So what happens is that, first thing, you will always talk about, number one, I will always talk about the nuclear charge. So over here, I compare the nuclear charge. By right, chlorine has the least number. I'm comparing Cl2, Br2, as well as I2. Down the group, chlorine, you should be able to recognize that it has the least number of proton, so it should have the smallest nuclear charge. By right, the smallest nuclear charge, the attraction of the outermost electron or the incoming electron, should be the weakest. But I also need to consider that the incoming electron is added to the outermost shell, and this outermost shell in your chlorine is actually the closest to the nucleus. I repeat again, chlorine, what happens is that the incoming electron is actually going to be added on the outermost shell of your chlorine. What happens is that this outermost shell is actually the closest to the nucleus, in the chlorine as compared to bromine and iodine. Because it is the closest distance, so the attraction between the nucleus and the incoming electron is going to be the strongest. Because it is the strongest, the ease of gaining electron is going to be the highest. So chlorine is going to be able to undergo reduction most easily. Hence, it is the strongest oxidizing agent. Can follow? Need to repeat? Repeat. Now, let me repeat this again. Even though chlorine has the smallest number of protons, which means the smallest nuclear charge, the incoming electron is added to the outermost shell, that is the closest to the nucleus as compared to bromine and iodine. Hence, the distance between the nucleus and the incoming electron in chlorine is going to be the smallest. Smallest distance, stronger electrostatic attraction. Chlorine is able to gain the incoming electron more easily. Itself is able to undergo reduction more easily. hence is able to oxidize other species more easily. It is the highest, the one with the highest oxidizing power. Okay, I give you around 2 minutes to take this down. Okay, read through this 2 times and try to understand what is happening. So I want to emphasize again, for group 17, there are 3 main things you need to know. The first is on volatility. Okay, the second one is actually on the trend of the oxidizing power down the group. The third one is actually on the thermal decomposition of group 17 hydrides. These are the 3 main concepts you need to know for group 17. Hence, this particular question is very important, especially the explanation. Okay, usually they will ask you, okay, to explain the trend of the oxidizing power of group 17 halogens down the group. This is the explanation you are expected to give. So take note, understand, memorize, and be able to recall. Okay, can I move on? Okay, moving on. When I look at B, okay, I'm bringing you through the thought process that you should have when you read the question. Once I read this question, first thing I'll recognize is that they talk about group 17 hydrides. Group 17 hydrides is represented with a HX. Then they tell me that it's separately heated. You are heating a group 17 hydride. Most likely this question, without even looking at subsequent information, I should be able to guess that it is going to talk about thermal stability of group 17 hydrides. If you look at this table, okay, what happens is that they give you the bond energy, they give you the observation. If you heat, okay, your hydrogen chloride, okay, what happens is that, okay, it will actually have no visible change, and then they give you a specific bond energy. The higher the bond energy means that the stronger the bond. A lot of more energy is needed to break the HCl bond. Okay, so that is why in this case you can see that as compared to HBr and HI, okay, which has a lower bond energy, HI you actually see dense purple fumes of I2, whereas for your bromine you see brown fumes of Br2. What exactly is happening? I need to be able to recall that HX in gaseous state, 2 moles of it will be decomposed on heating to form H2 gas plus X2 gas. Okay, so the brown fumes that you see, okay, is your X2. Meaning to say that most likely your hydrogen bromide would have undergone decomposition by the heat. Okay, so when I look at this table, this should go through my head. Next part is that they ask me, okay, based on the observation, state the thermal stability. What do we mean by thermal stability? Okay, let's just go through the flow of thought again. Okay, when I say thermal stable, okay, when I say something that is more thermal stable, means that it is less likely to be decomposed by heat. So understand that when we use the term thermal stability, if I say a compound is more thermal stable, means that it is less easily decomposed by heat. In the presence of heat, it does not decompose easily, it is more stable. Okay? Meaning to say, why is it that it does not easily decompose by heat is because your HX bond is actually stronger. Okay, so that is the link of how I draw the bond strength to the thermal stability. Okay, you may want to take this down if you're often confused of what thermal stability is about. So here, if I look at HCl, the HCl bond is the highest. If it is the highest, means that it's going to be the most thermal stable. It is least likely going to be decomposed by heat. Hence the trend, HCl is more thermal stable as compared to HBr, as compared to Hi. Okay, and then more importantly, I need you to take note, okay, how different, there are many different ways to represent thermal stability. I can say that thermal stability of group 17 hydrides decreases down the group. Another way I can phrase it is that they can ask you to describe the trend of the decomposition temperature down the group. You know that down the group, it becomes less thermal stable, meaning to say it becomes more easily decomposed by heat. So you will actually require lower temperature to decompose your group 17 hydride. Hence, the decomposition temperature decreases down the group. Can follow? Okay, I want you to write this 4 points down. Next thing is the ease of thermal decomposition. It becomes more easy to decompose your group 17 hydride. Okay, hence, ease of thermal decomposition increases down the group. Because it becomes easier to decompose, we say that the extent of thermal decomposition increases down the group. These are 4 different ways that I can talk about thermal stability. You may want to write it down. Not may, you have to write it down. Okay, so sometimes question may be phrased differently, but that is the general trend, okay, of thermal stability. These are the 4 different ways they can phrase it. So please take note of it. Can? Okay. Last part is that when they ask you to explain in terms of bond energy, okay, so in terms of bond energy, when the question asks you to explain in terms of bond energy, read the question. Means that definitely in my answer, I must mention something about bond energy. Okay, so I will quote the bond energy value in your data booklet. Look at how I represent my information. I will just put bond energy of HCl higher than bond energy of HBr, higher than bond energy of my Hi. Down the group, HX bond energy it decreases. Because the bond energy decreases, that's why I say that less energy is needed to break the HX bond. Okay, hence, okay, the thermal stability decreases down the group. Because the question is a 2 marks question, you should be able to explain and account for the decrease in bond energy down the group. Okay, this is under chemical bonding. So I want you to take note of the second point. Okay, so what I need to mention is that down the group, the size of the halogen atom increases. So the orbital becomes what we call more diffuse. The effective overlap, the overlap becomes less effective. Bond length increases, bond strength decreases. Okay, so that is to explain why is it that the bond strength of your HX bond decreases down the group. Okay, because this is a 2 marks question, you are expected to give the explanation for the trend of the bond strength down the group. I repeat again, because this is a 2 marks question, so that is why you are expected to give the trend, okay, of the bond energy, the decrease in bond energy down the group. Okay, and that is how I explain to talk about in terms of the size of the orbital and the effectiveness of the overlap of the orbitals. Can? Okay. Okay, I know some of you are sleepy after lunch. Okay, so try to stay awake. Try to actively write down things. Okay, to keep yourself engaged. Okay, if let's say you need to stand at the back, okay, to do some exercise also can to keep yourself awake. Okay, now the next one is a similar concept. Okay, under certain conditions, hydrogen halide decompose. Thermal decomposition again. Now the first part, okay, of the answer is good for you to know. Okay, how do you carry out this reaction? One way that you can carry out is to insert a hot wire or glass rod, okay, into a test tube of the gas. Okay, I know this is not in your lecture notes, so now it's good for you to know how this thermal decomposition of your group 17 hydride could be carried out in the lab. This is one way that it can be carried out. Okay, so you just jot it down and then now you know. Okay, but more importantly, okay, they are asking you to describe what will be observed in the case of your HI. In your HI, okay, you know that the general trend of thermal stability of your group 17 hydrides down the group is that it will actually become less thermal stable. Thermal stability decreases. Hence, your HI will actually decompose to form hydrogen gas and iodine gas. If you look at your lecture notes, iodine, typically at room temperature, the state of iodine is actually solid. But why is it that I'm putting gas here? Is because you are doing a decomposition. In the reaction mixture that you are doing the decomposition, the temperature is higher than room temperature. Meaning to say the temperature is a lot higher, so your iodine will exist as gaseous state. That is why over here, the state symbol that I've put for iodine is gaseous state. It is not at room temperature. You should not be putting solid. Okay? Next thing, I need you to be able to recall, if let's say the question changed to either HBr or HCl, you should be able to describe the color of the respective gases. Bromine, reddish brown. Chlorine is actually pale yellow. Okay, make an effort, put the asterisk, remember the color of the respective halogen gases. Okay? Okay? Can? So if you are feeling sleepy, okay, tap your friends up. Okay, sometimes because your eyes are too small, I don't know whether you are closing your eyes or whether you are dozing off. Okay, so help to tap your friends to wake them up. Now, the next part is that you use bond energy from data booklet to calculate delta H of the reaction. This thermal decomposition, right? If let's say, okay, not just for this question, but for let's say energetics, okay, I want to use bond energies to find the enthalpy change of the reaction. Of course, I know that, okay, the sum of the bond energy of the bonds broken minus the sum of the bond energy of the bonds formed. If it is very hard for you to see from the equation, just draw out the structure to see what bonds are present. This is very easy because it is a very small molecule. If you have a much larger molecule, okay, you need to draw all the bonds out. Draw the full displayed formula if you really cannot see. Here, I know that my HX bond is broken. There are 2 moles of HX bonds that are broken. Hence, over here, if you look at the equation, I multiply the bond energy of HX by 2. Okay? Then, you are actually forming 1 mole of hydrogen-hydrogen bond and 1 mole of your XX bond. Okay? Sub the values inside, you should be able to get that for, if X is your chlorine, you should get positive 182 kilojoules per mole. For I, it is positive 11 kilojoules per mole. Gentle reminder again that whenever you are writing for enthalpy change of reaction, you are expected to give the sign. Okay, if it is positive, you still need to put a plus in front. If it is a negative, you put a negative. And units needs to be given kilojoules per mole. Two things, sign plus unit, you must include for enthalpy change of reaction. Okay, check your answer. The next part, when they ask you to explain how the extent of decomposition vary down, using your result from A part 3, means to say that in your answer, because the question states that I need to make reference to A part 3, you have to link it to the enthalpy change of the reaction. Okay, and then here, based on the enthalpy change, down the group, what happens is that it becomes less endothermic. Take note of how I phrased my answer. I did not say that the enthalpy change become larger or smaller. I will not accept if you say the enthalpy change become larger or smaller. Whenever I describe enthalpy changes, okay, you will say that either is it less endothermic, more endothermic, less exothermic, more exothermic. This is the term that you should be using. You should not be using larger or smaller. Okay, because it is less endothermic, okay, means that it requires to absorb less energy, okay, for the reaction to occur. The extent of decomposition, okay, increases down the group. It is decomposed to a larger extent because we understand, based on what we learned in theory, is that down the group, the thermal stability decreases. It becomes less stable. Your group 17 hydrides become less stable. It is decomposed more easily. Decomposed more easily means that the extent of decomposition increases down the group. That is how I check. So two parts to this answer. First one is to link that the reaction become less endothermic. The second one is to give the conclusion that the extent of decomposition increases down the group. Okay? Any question? I mean, nobody will ask, so I just ask for the sake of asking. Let's move on. Now, next part, okay. You are comparing sodium, magnesium, aluminum, silicon, salt. Okay, you are comparing all these elements in period 3, okay, and state the difference between the ionic radius. So same thing, okay, when I talk about the ionic radius, generally to describe ionic radius, atomic radius, things that I always need to mention is number one, okay, your nuclear charge. Okay, nuclear charge will be linked to the number of protons. The second thing I will also consider is actually the shielding effect. Okay, shielding effect, generally you talk about the number of electron shells. The third point is I will compare nuclear charge and shielding effect. Then you have a conclusion on the effective nuclear charge. Okay, and then you end off to talk about in terms of the electrostatic forces of attraction between, okay, your electrostatic attraction, okay, between nucleus and your outermost shell. Take note of I'm using the word outermost shell, okay, because for ionic radius, I'm going to use the word outermost shell. Okay, for ionization energy, I'm going to use outermost electron. Okay, so take note of the difference. Here, okay, generally, okay, you should know that for N ions, the ionic radius is going to be larger than the cations. So the first point you need to talk about is to compare the ionic radius of the N ion with the cation. And also, okay, based on that, you should be able to explain clearly that your N ions have one extra electron shell. Because of that, it will have a larger ionic radius. Okay. Next one, okay, within the same isoelectronic series. If you still do not know what is isoelectronic series, it just means that they have the same number of electron. Okay, so P3 minus as compared to Cl minus, they have the same number of electron. Across the period, what happens is that your Cl minus will have a larger nuclear charge. Why? Because it has more number of protons. First thing I talk about, nuclear charge. Because they have the same number of electrons, so that is why your chloride ions, okay, and also your P3 minus have the same shielding effect, approximately the same. Effective nuclear charge of chloride ions is higher, okay, because the nuclear charge is higher, but the shielding effect is sama-sama, it's almost the same. That is why the effective nuclear charge of chloride is going to be higher. Outermost shell is going to be more strongly attracted to the nucleus. That is why ionic radius is smaller. Can see the flow? Okay, I give you around 1 minute to read through this. So I just want to do a quick recap. Okay, whenever I have first ionization energy, atomic radius, ionic radius, okay, the 4 points that you need to mention in your answer: nuclear charge based on number of protons, shielding effect based on number of electrons, effective nuclear charge, which is to compare your nuclear charge and shielding effect, and lastly you conclude with the electrostatic attraction between nucleus and the outermost shell or electron. Is that clear? So that is just a trend for you all to be able to understand and remember whenever you want to explain for atomic radius, ionic radius, and first ionization energy. Can? Okay? This topic is not difficult to score. Okay, basically you need to be able to go and read up your lecture notes. Okay, those things that your tutors and myself ask you to go and memorize and be able to recall. Okay, you make sure you go and be able to recall. Okay, usually it is this topic is recalling question. Okay, you need to put in the effort to go and memorize the explanation, the trend, and also writing out the equation. Now the next one, okay, is the same old thing that we have talked about many times. Okay, we have talked about melting point. Whenever you want to discuss melting point, a physical property, you always talk about soft boil pigeon egg. Structure, bonding, particles, and energy. We have been talking about this many times, and you need to make sure you know how to identify the structure, bonding, and particles. The first thing I'll remember is always that silicon out of period 3 is going to have the highest melting point. That is the thing I'll make sure I go and memorize. So whenever if you're given a sketch of the melting point, okay, across period 3, I know that the highest point will be silicon. I repeat again, make an effort to memorize that silicon has the highest melting point across period 3 element. Why? Structure, giant covalent structure or giant molecular structure. Bonding, strong covalent bond. Okay. Particles, atoms. Energy, a lot of energy is required to break the strong covalent bonds. Just like that, 1 mark. Okay, it is free flow. Then you go and compare sodium. Sodium, structure, giant metallic structure. Bonding, okay, strong metallic bond. Particles is between delocalized C or valence electron and metallic cations. Then, okay, you tell me specifically, because in this question they ask you to tell us how the melting point differ. So you are expected to compare the strength of the bonding. Meaning to say that you need to tell me that metallic bonds are stronger than ID-ID interaction. Do not just write ID-ID interaction. You need to spell out in full, bracket ID-ID, then subsequently you can use ID-ID. Okay, in P4 and Cl2. Can you see that if you still do not know, phosphorus is a simple molecule. It will exist as P4, not P2. Okay, chlorine, Cl2. Okay, then you conclude to tell me that the sodium only have one valence electron per atom that is delocalized. That is why it is weaker than the covalent bond in silicon. Okay. Last thing, okay, when you want to compare ID-ID interaction, I know that P4 and Cl2 has simple molecular structure. That is the structure. Bonding is your weak ID-ID interaction. Particles is between molecules. When you want to talk about ID-ID interaction, you will compare the size of the electron cloud. And very commonly miss out, I mentioned this before, that you forget to tell me larger electron cloud means more polarizable. More polarizable, stronger ID-ID, more energy is needed to overcome the stronger ID-ID interaction. Okay? Read through this again, read through your answer, take note of the difference, add the missing point in. Okay, keywords that we highlighted, okay, that you commonly miss out, take note. So you see that the format of answer whenever we discuss melting point, boiling point, solubility is always structure, bonding, particles, and energy. Soft boiled pigeon egg. Take note. Can? Okay, moving on. Last part, acid base. Do you know why when magnesium meets oxygen, okay, magnesium is very shocked? Because OMG. Okay, never mind. You're expected to laugh. Okay. I know all the chemistry joke are gone. That is why no reaction. If you don't understand, you need to go and read back your periodic table lecture notes. Now, okay, here, acid-base property of aluminum oxide. Okay, aluminum oxide is something special. You know that it is an amphoteric oxide. Okay, it is able to react, okay, with a base as well as acid. Okay, it is insoluble in water. pH of solution when you dissolve aluminum oxide is going to be 7. But that doesn't mean aluminum oxide is neutral. Aluminum oxide is not a neutral oxide. It is what we call an amphoteric oxide. If you add acid or if you add base, your aluminum oxide can react with either the acid or the base. This special property, remember. So why is that so? First thing, okay, I will have to explain that it is both basic and acidic. It is what we call amphoteric. That will give you 1 mark. Second thing, why is that so? Is because it is an ionic oxide with what we call covalent character. Al3+, okay, is small. 3+ means that it is high charge. Small cation with high charge is what we call high charge density. Take note of this term. High charge density cation will mean that it have a great polarizing power. Okay, with O2 minus, okay, what happens is that it is able to polarize, okay, your O2 minus, okay, there is some degree of sharing, and this some degree of sharing accounts for the covalent character. Okay, so how you should phrase it is that first thing you tell me that Al3 plus, small and highly charged, high charge density, great polarizing power, 1 mark. Second point, okay, mention to me that the polarizing of the O2 minus give the ionic bond, okay, some covalent character. That is the second point. Because of this ionic bond with covalent character, that is why it tends to be able to act as an acid and base at the same time. Because understand that if you have a magnesium oxide is actually an ionic compound. Ionic compound, okay, tends, okay, to be a basic oxide. Whereas your phosphorus oxide, which is a covalent compound, tends to be an acidic oxide. So if you have both ionic and covalent, you have best of both worlds. You can act as a base, you can act as an acid. It is what we call amphoteric. Understand? That is why here you can see that Al2O3 is able to react with HCl. Okay, take note that the arrow should be an irreversible arrow, a full arrow. Acid-base reaction are irreversible. Next thing, recognize, okay, what is the respective state symbol. Aluminium oxide, solid state. React with aqueous, HCl, okay, to form Al3 plus, Cl minus, H2O, liquid. Know how to balance it. Acting as a base, react with sodium hydroxide. Take note, the product is formed is AlO4 minus. During lecture, I told you to pay special attention to this product, so take note. Okay? Check. Okay? These two equations is very commonly tested. Okay, so you make sure now you learn how to balance the equation. Okay, you should not be trying to balance the equation during exam. You should be able to write out the balanced equation in exam already. Okay, so in your free time, write down a few times. Okay. Now, last part, question 3. Okay, I've talked about oxides. Now I talk about chlorides. So if I want to compare for chlorides of magnesium, aluminium, and phosphorus, this is a very common type of question. Okay, very common that they ask you, okay, to describe the reactions of the chlorides with water. Okay, so first thing, some keywords you need to take note of is that for MgCl and AlCl3, MgCl2 and AlCl3, what happens is that the Mg2 plus and the Al3 plus, okay, gets hydrated. The first step is to get hydrated. Okay, hydrated means that, okay, the Al3 plus will be surrounded by water molecule, okay, by ion dipole interaction. Okay, so redraw this. Okay, so it will be able to surround your Al3 plus or Mg2 plus. Wrong. Okay, by ion dipole interaction. This is ion dipole interaction. Okay, once it surrounds your Mg2 plus and Al3 plus, what happens is that for Mg2 plus has a lower charge. Okay, so the charge density is moderately high, not high, moderately high. So it undergoes what we call a slight hydrolysis. The words that I think is the words that we are looking out for as keywords in your answer. You are expected to include in your answer. Slight hydrolysis, it will give a pH of 6.5. Equation, first one, okay, is hydration, followed by the second one, which is your hydrolysis. Take note that for the second arrow, okay, for the second equation, it is a reversible arrow. Okay, it is weakly acidic. That is why it dissociates partially to give you your H3O plus, accounting for the pH of 6.5. I'm not going to explain again, okay, why is it that it's able to undergo hydrolysis. That is in your lecture notes. Please go and read up if you do not understand. Al3 plus, same thing, hydrolysis, hydration followed by hydrolysis. pH is slightly lower, okay, because hydrolysis occurs to a larger extent. Okay, so take note, okay, of how to write, okay, the product that is formed after the hydrolysis. Okay. PCl5 undergoes hydrolysis to form H3PO4 and HCl. pH 1 to 2 accepted. Okay, check. Generally, if you dissolve your chlorides, period 3 chlorides in water, okay, the pH should be less than 7 and below. Okay, remember the graph that we have sketched out. Okay, the pH of solution would be 7 and below. Take note. So what influence the type of bonding present in chlorides? Okay, so usually for ionic chlorides, okay, it will give a slightly neutral, it will give a neutral or slightly acidic solution. If you have covalent chlorides, it will give acidic solution. Okay, so take note, the type of bonding will affect, okay, whether it undergoes, it will affect the reaction with water. Okay, covalent chlorides usually give acidic solution through hydrolysis. You want to take picture, okay, but once you go back, you make sure that you put in the effort to rewrite it out again, okay, in order for you to be able to understand and recall, okay. Like I told you, many of periodic table questions are recalling questions. You need to put in the effort to recognize the trend, to understand the trend, and to be able to recall the explanation and equation, okay. Last part, okay, before we call it a day, okay, this is when they tell you that aluminium, okay, unlike aluminium, boron, okay, is a non-metal, okay, and share more similarities with carbon and silicon. Okay, so here, okay, reading in the context of the question, okay, they tell you that boron, okay, by right, boron, okay, should have similar properties with aluminium because they are in the same group. But in fact, the question tells you that it doesn't. Then you need to start to recall, oh, what particular area of periodic table do I learn this? Once I read the question, I'll roughly think, oh, maybe it is a diagonal relationship, okay, whereby beryllium, okay, will have similar properties as aluminium. In this case, your boron has similar properties as either your silicon or carbon. This is what I call a diagonal relationship. Okay, they will react similarly. Okay, so over here, okay, I try to make a comparison. You should be able to recall what happens if your silicon chloride, okay, reacts with water. Okay, question tells you that it undergoes hydrolysis to give compound M and white fumes. If there is white fumes, understand that white fumes is usually HCl. So most likely HCl would actually be produced. Okay, so I draw a comparison. Okay, either one is fine. Okay, you can be either one of the equation. I draw a comparison, okay, with your silicon chloride. Okay, so that is how I approach the question. Okay, so over here, the bottom line is that for this particular topic, you really need to put in the effort to understand the trend, able to recall the trend, the explanation, and also the equation. Okay? Okay, so that is all for periodic table. I'll pass on to Mr. Tan.
Okay, guys, before you go, please listen to the following announcement. In a way, congratulations. You finished the third last topic. All right, you have 2 more topics to go only. And very thankfully, I found very good lecturers for you guys for the next 2 topics. So you're in for a treat. So look out for the message, all right, to tell you, okay, to collect your lecture notes and also answers for the recent or answers for organic tests recently was very badly done, Organic, you must study the whole thing. You must summarize the whole thing. You must see the similarity and differences. Okay? So organic test wasn't very well done. Friday, when we see you for lesson, we'll go through with you individual classes. But you really need to do something about organic. Understand, some of you? Many of you. Okay? Guys, listen. One thing I need to remind you, when we send things for printing and tell you to go and collect, you must go and collect. It's already print for you. Okay? Understand? So you must go and collect. Your name list is with the photocopy auntie. You never collect, we can trace you very easily. Understand? So please help us, help yourself, help the auntie there. Must make sure you go and collect and do your stuff. Alright? Okay, one last thing is I only want to see students from the following classes: 1811, 12, 20, 21, and 22. The rest of you, you may go. Look out for further information from us for this Friday and next week's lecture. Thank you. You may go. Students from 1811, 12, 20, 21, and 22, can you please stay for a short while? Thank you.